Okay, here we are. We're in section 4.1, and we're going to be discussing quadratic functions throughout the full chapter 4. A little tune that you guys are going to get very familiar with over the next chapter is the quadratic formula song, and we'll have a lot of fun with that this chapter. The quadratic formula song goes a little bit like this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a hoo. And that will come and go throughout the entire chapter, and we'll have a lot of fun singing that. The first thing we're going to talk about is what is a quadratic function. A quadratic function is a function of the form y equals ax squared plus bx plus c. And when you graph that on your calculator or by hand, it will make a parabola, which is a U-shaped figure, and it kind of looks like that. You guys have probably done something like that before. The vertex is either the top or the bottom point. In my graph right over here, the vertex would be that point right there on the bottom. The axis of symmetry, is the axis that cuts something right down the middle. So if that were your face, our axis of symmetry would be what goes right down the middle. The minimum and the maximum value, that it would be that vertex point that we were talking about. If a parabola had a minimum point, it would open up, and that minimum point would be right there. And if it had a maximum point, it would open down, and that maximum point would be up there. Basically the point where it either goes as high as it can go or as low as it can go. Our parent function, remember we always have these different parent functions. Our parent function here is y equals ax squared, and that's the most basic as it can be. It has a vertex right on the y-axis, right at 0, 0 is that vertex there. And the axis of symmetry for that graph is x equals 0. So that axis of symmetry runs right down the middle there. That function is commonly known as f of x equals x squared. So if you throw that into your calculator, you will see what that would look like. If we go over here to page 2 of 4-1, we're on page 93 currently. In page 2, we're looking at the graph of a function of a more basic form than the y equals ax squared plus bx plus c. You'll notice it does not have a b. It's missing the b there. So it's just ax squared plus c. So let's see what happens when we have y equals ax squared plus c, or in this case we have y equals negative 2x squared plus 2. And we want to compare it to what y equals x squared looks like, which they've already conveniently graphed for us right here on our graph. Probably the easiest way to start by graphing these by hand is just to do an xy table. And if we do an xy table with these things, some good points to pick would be negative 2, negative 1, 0, 1, and 2, as long as the vertex is at 0, 0. So when the vertex is at 0, 0, we can graph those points. So we put negative 2 into our original. So I'm going to do it right over here on the side. Y equals negative 2 times negative 2 squared plus 2. Negative 2 squared, because it's a negative being squared, it becomes positive. 4 times negative 2 is negative 8 plus 2 equals negative 6. So I have the point negative 2, negative 6, 1, 2. They're in twos. So it's negative 2, 2, 4, 6. A little point right there. Put my negative 1 in there. Negative 2 times negative 1, quantity squared plus 2. Negative 1 squared is 1. 1 times negative 2, negative 2, plus 2. And it looks like I'm going to end up with 0 here. So I have negative 1, 0. So negative 1, 0. It looks like I got a little dot right there. And if I put my 0 in there, I end up with negative 2 times 0 squared plus 2, which is just 2. So I have the point 0, 2. Looks like I got a dot right there. And then what we'll start to see here, because there's not a B number, which is going to move it from left to right, what you'll start to see here is that the graph might turn back around right here. So let's take a look. We put a 1 in there. We get negative 2 times 1 squared plus 2. 1 squared was 1. Negative 2 times 1 is negative 2 plus 2. Look at there, we got a 0. And see how that turned back around. So it went up, hit this top point, and remember what that top point was called? Vertex. So right here, we found our vertex. Looks like it went up, and now it's starting to come back down. And at this point, I can make an assumption that 2 is going to be perfectly symmetrical. So 2 is going to have negative 6. But let's just check. Negative 2 times 2 squared plus 2. 2 squared is 4. 4 times negative 2 is negative 8 plus 2. And look at there, we got negative 6 again. And so this thing is perfectly symmetrical, and it looks like it goes up, comes right back down. Okay? So I drew a smooth curve through the points. When we compare the graphs of this to y equals x squared, when we look at the two, both graphs have the same basic shape, but the one thing that they share in common is an axis of symmetry. However, the graph y equals negative 2x squared opens down, and is, I would say, maybe skinnier or narrower. It's certainly thinner. So let's go with the word narrower, or more narrow than the graph of y equals x squared. Also, its vertex is it's a little bit higher. You'll notice it's 2 units higher, and that would give me an idea of where that's at. When we look at the properties of the graph, there's a lot of things we can tell just by looking at the equation. The graph opens up if A is above 0, meaning if A is positive, because positive people smile, right? Because positive people smile, right? Then it's going to open up. And if A is negative, because negative people frown, then A is going to open down. So that's an easy way to remember that, the A, and if it's positive or if it's negative. The graph is narrower than the graph y equals x squared if the number A, or the absolute value of A, meaning A is 1, 2, 3, 4, it's greater than 1, or if it's negative 1, negative 2, or if it's greater than negative 1, so negative 2, negative 3, negative 4, that's going to make it a little bit more narrow. And it's going to be wider if we're talking about numbers like 0.5, 0.75, or negative 0.5. Those become fatter or wider. It's very similar to what we learned about in our absolute values, how that graph changed sizes. The axis of symmetry, with our graph here, when we have x, it's going to be the opposite of b over 2a. Now you remember that song I sang, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Well, look here. You got the opposite of b over 2a, and that's always going to be your axis of symmetry. So those are pieces of that song that we will continue to sing over and over and over again. the axis of symmetry is x equals negative b over 2a, and the vertex is always going to have that same x coordinate, opposite of b over 2a. So that's going to become important to us. The y-intercept, remember, just like with y equals mx plus b, the y-intercept is always going to be c. So the point 0c is always on the parabola. On to page 94 now.